So what's important for us is to not build a robot for the lab, but for these very harsh environments. So quickly understanding these robots are going to be exposed for many, many months and years to outside environments. So building a system that's completely water and dust proof, that's very important. So as we design the systems, the sealing, etc., it's all very closed off. At the same time, what you need to take in consideration, you need to take the heat out from the actuators, from the compute. So having advanced thermal management system is something we have heavily invested in. Now, we took that quite far, and the next frontier was with ANYMAL X, a robot that could go into potentially explosive environments. Now, these are environments where you would have gases that you're not allowed to ignite through a spark or a heat source that could cause an explosion. Obviously, creating an explosion in these environments would be very bad, and so there's strict protocols called IECEx or ATEX certifications that you need when you introduce a device. That meant that we needed to develop a special robot that also complies with these certifications. So in our case, the robot is flooded with an overpressure of nitrogen, making sure none of the gases come in. The robot has special battery chemicals. The motors are enclosed differently. All the sensors are packed in. So a lot of engineering went into building essentially the same robot, but for this explosive environment. So certainly it's quite challenging, but it's also highly rewarding because we can really push here the frontiers on how robots are being used.